So friends, I totally agree with you that if this question is being given in an exam, guys, the first method that comes to my mind is the method of trigonometric substitution. But friends, we shall answer this problem without the use of that method, but with the use of U-substitution. Okay, so friends, we will start by factoring out the bottom. If we factor out the bottom, guys, we are going to have the integral of 1 over, we are going to have x squared. This one stays the same. Then guys, the interior of this square root, we are going to factor out x squared. If we do that, we are going to have x squared into x to the power negative 2 minus 1. If we multiply this bracket out, guys, we have the same factor that we have in the denominator. So guys, at this point now, we see that x squared can come out of the square root as x. We are going to have the integral of 1 over, we have x squared. Then we have x, which comes outside. Then we have the square root of x to the power negative 2 minus 1. So guys, multiplying x and x squared gives us x cubed. We can send the x cubed at the top. When it goes up, we are going to have the integral of x to the power negative 3 over the square root of x raised to the power negative 2 minus 1. At this point now, guys, can do a u. So if we let our u to be the bottom, which is x squared minus 1, then guys, du gives us what, guys? Gives us minus 2x raised to the power negative 3 dx. That is, if we multiply minus 2 here, we're going to have minus 2. Subtracting 1, we're going to have x to the power negative 3. Division negative 1, guys, gives us 0. So guys, this our integral now translates into, we are just going to have the integral. So guys, but before then, guys, it is also good that we can transform this integral into a form that we can easily handle. By so doing, we want to have minus 2x to the power negative 3 in the bottom, at the top, sorry. So by so doing, we are going to insert it. But guys, it has changed the whole issue. For us to balance it, we can multiply in the exterior by minus 1/2. Since minus 1/2 can cancel with this, we have x to the power negative 3. So guys, in this case now, we can see that what is minus 2x to the power negative 3 dx is simply what? Du, right? So if we do that, we're going to have minus 1/2 integral of just 1 over square root of x to raise to the power negative 2 minus 1 is what? U, right? So we're going to have the square root of u du. So we can write 1 over square root of u as u raised to the power minus 1/2. If we do that, we are going to have minus 1/2 integral of u raised to the power minus 1/2 du. At this point now, guys, we can do the reverse power rule. We simply add 1 to the power and divide by the new power. We are going to have this minus 1/2 stays the same. If we add 1 to minus 1/2, we're going to have 1/2. Dividing 1/2 by 1, we are going to have what? 2, right? Then x to the power what? 1, then u raised to the power what? 1/2. So in this case, guys, 2 can cancel with 2. We just have what, guys? We just have minus u raised to the power 1/2. So in this case, guys, the integral of 1 over x squared into 1 minus x squared, guys, can simply translate into, we have just minus, what is u, guys? Is x to the power negative 2 minus 1, right? We have negative of that plus c. Great. So guys, thank you for watching the video, guys. Thank you so much. Subscribe to this channel, guys, if you want to have more great content from us, guys. Subscribe to the channel. Watch the next video, guys, because it's going to be super interesting, guys, for you. Have a blessed day, friends, and please give the video a like. Hello, dear friends. We shall be looking at the correction of the Advanced Level Southwest mock. That's the Physics Paper 2, question 1 of 2025. So guys, the question is that a communication satellite occupies a parking orbit around the Earth such that the radius r0 of the orbit is given by r0 equals the cube root of gmt squared over 4 pi squared, where capital T is the period of revolution of the satellite, g is a universal gravitational constant, and m is the mass of the Earth. Now the A part is saying that we should determine the base units of G. Okay, now guys, let's take it bit by bit. So friends, let's start with the formula that we have. The formula as stated, it's simply, we have it as r0 equals the cube root of gmt squared over 4 pi squared. So guys, in this case, to get this question done, we have to start by making our G the subject of this formula. If we do that, we are going to have, if we do that, we need to take the cube root of we need to cube both sides, guys. If we cube both sides, we're going to have r0 cube equals gmt squared over 4 pi squared. Making G the subject, guys, we have G to be something like 4 pi squared r cube over mt squared. So guys, our assumption in this case is that the equation is homogeneous. Of course it is, guys. So in this case now, we can say that the units of g has to be equal to the units of 4 pi squared r cubed r0 cubed over mt squared. That therefore implies, guys, we know that 4 pi squared is a unitless constant. It is a constant. 4 is 4, pi is 3.142, and so on, guys. Squaring that still gives us a constant. So guys, it's unitless. As such, guys, the units of r0 cube is equal to meters cube, since r0 is a radius, that is a distance, so it has to be measured in meters. So we have r0 cube, the unit to be the same like m cube. Then now, guys, the units of m, which is the mass of the earth, is what, guys? Kilograms. And the unit of t squared, which t is period, and the SI unit of period, guys, is the seconds. So in this case, guys, we are going to have what the unit of t squared be something like what? S squared. That therefore implies, guys, the units of g has to be the same as the unit of 4 pi squared. Like I said, is a constant. R0 cube has unit meters cube, so we are going to have meters cube over kilogram second squared. If we simplify that, we have the units of g to be the same as meters cube per kilograms per second squared. Okay, so guys, the first part has been answered. Then now, friends, the B part is saying that we should calculate r0, the radius of the planet. Okay, so guys, we have to use our formula that the equation has given us, r0 to be seen like the cube root of gmt squared over 4 pi squared. Okay, so guys, in this case, we have to simply plug in all the values that we know. Note that g is the universal gravitational constant, and its value is in your formula booklets. M as well, the value is in the formula booklet. We are going to use 6 times 10 raised to the power 24 kilograms. T in this case, guys, is simply the period of revolution of that satellite. Keep in mind that since the satellite occupies a parking orbit, it never means that it is likely going to be what, guys? A geostationary satellite. So in this case now, friends, our T in this case, since it's a geostationary satellite or a geosynchronous satellite, our T has what, guys? 24 hours. That's the period of revolution of the Earth. So in this case, guys, if we plug in everything, our G is what? 6.67 times 10 raised to the power negative 11. Our M is 6 times 10 raised to the power 24 kilograms. Our T is 24 hours, but we have to convert that hours to seconds. So we have 24 times 3000 times 3600. Everything squared. Then we have our 4 pi squared. So guys, we simplify that. We have an answer of r0 to be something like 4.23 times 10 raised to the power times 10 raised to the power 7 meters squared. So guys, that is simply the radius of the satellite. Okay. Now, friends, the next part wants us to hence calculate h, that is the height of the satellite from the Earth's surface, and state any assumption that we have made in our calculation. Okay, so guys, let's picture out exactly what's happening. This is the Earth. This is the Earth. That's the Earth, guys. Then now, friends, let's simply insert the radius of the Earth. Let's call that the radius small r. Then, friends, this is going to be the this is going to be the orbit of the satellite. Let's call this the satellite's orbit. Then now, friends, let's start the radius of this orbit, guys, is given as r0 as the equation suggested. Then now, friends, let's insert the satellite to be at this point. Then now, friends, at this point now, let's name that this is our satellite. Then now, friends, let's insert the height that the equation wants us to get. That is the height of the satellite from the surface of the Earth. So let's call this guy capital H as the equation has given. So friends, in this case now, do you see that our H has to be given as the difference between r0 and r? So in this case now, friends, we have what do we have, guys? We have r0, right? And we know r, that is the radius of the Earth from the formula in the formula booklet, right? So in this case, guys, if we plug in everything, guys, we have our H to be something like 4.32 times 10 raised to the power 7 minus 0.64 times 10 raised to the power 7. Simplifying that, guys, give us an answer of about 3.59 times 10 raised to the power 7 meters. If we can put this guy, friends, to two significant figures, we are going to have it to be 3600 kilometers. Great. So guys, this is simply the height of that satellite from the Earth surface. Now friends, what assumption have we made? What we simply used was that the centripetal force in this case, guys, is divided by what? The gravitational force. That is the assumption that we have made in this case, because that is the assumption that was used to derive this particular formula. Great. So guys, that's it for the video. If there's something you don't understand, friends, feel free to reach out to me in the comment section down below, guys. I'll make you understand by explaining further as soon as possible, guys. Have a blessed day.